Hello friends, my name is Akshay and we will solve today's Geeks for Geeks question. The question is perfect number, okay? So read the question definition. Given a number, okay, we have a given n number. Check if number is perfect or not, okay, so we have to check it. And then a number is said to be perfect if the sum of all its factors excluding the number itself is equal to the number, okay. So we have to first find factors of for n, and then we can edit we can addition all factor and then check if the summation of n is or not, and we have to exclude n itself. Return 1 if number is perfect, otherwise 0, okay. So see the example. N is 6, output is 1 because the 6 is perfect. But how? Let's we see. Factor of 6 is 1, 2, 3 and 6, but 6 we have excluded, so here we consider only 3 these factors, and then we make sum of these 3 factor, so it will be 6. Yes, so it is a perfect number according to the definition. The factors of 10 is 1, 2 or 5, and the sum of 1 plus 2 plus 5 is equal to 8, which is not equal to 10. Yes, so the 10 is not a perfect number, so it will returning the 0. It's okay. So in this case our time complexity is up to only square root of n. So in general approach, what we will do? We will do to take for loop from 1 to n minus 1, and we have to check if it is divisible by n or not. If is it divisible by n, so we take sum in it, and then returning the and then check sum is equal to n or not. This is our general approach. But in general approach it will go up to n minus 1, but here mentioned that our time complexity is square root of n. So how we can solve it? So let we say we start sum with 1, because we know 1 is always the factor of any number, okay. So 1 is factor of every number, so here we write sum is equal to 1. Before doing this, we check if n is equal to 1 or not. If n is equal to 1, so returning 0. Why? Because the factor of 1 is 1, and we have to excluding 1. So if we excluding 1, let me draw. Okay. If we have to give an n is a 1, so what is the factor of 1? Factor of 1 is 1. In our sum variable, assume initially sum has 0, okay, but the factor of 1 is 1, so we have excluding it. So sum is 0 and our number is 1, okay. Number is 1 and sum is 0, so both are does not equal to. It means we have simply returning 0, and we start sum with 1, because rest of all elements all have factor as a 1, so we start with 1, and our for loop start with 2, and we know we have to go up to square root of n. Okay, so how can we take after number after square root of n? Because assume we have to given n is 28. Okay, so what is the factor of 8? Factor of 8 is 1, 2, 4, and 5 is not, but 6 is not, 14 and 7. This is factor of 28. So take the sum of them, 3 and 7, 7, 21 and 7, 28. Yes, this is equal to 28, we can see that. But we will go I is equal to 2, I is equal to 2, 2, I is equal to square root of n. And what is the square root of 28? We can say that something 5.1, but I is integers, so it take 5. So we will go up to this. So up to this we can find, because this is less than of square root of n. This number is less than square root of n, so we cannot find this number, but we have to find this. So we can do one thing, that we find this number, okay, and we divide this number to this, okay. So we have divided 28 by 2, because 28 is multiplied by 2 factor, any 2 factor or any 3 and 2 factor, so we can take 28. So if we divide 28 by 2, so it will give me 40, okay, and we divide 28 by 4, so it will give me 7. Yes, so like this we can divide, but we don't included 1, so we start I is equal to 2 to I is equal to square root of n, and we take sum. Our sum plus we added I, within this we added n by I, means these elements after square root, n by I, because n is a multiply of two number. If one number is the a factor of n, so we can find another factor by this factor. By dividing, we divide n with one factor, so it gives me another factor which is after the square root. We find just before square roots all factor of the n, and we dividing this factor and find after the square root of n, okay. So like this we have to find our sum, but we have to check I does not equal to 1. If I is equal to 1, so it will add 28, but it is not possible, so I does not 1. And another one thing is, if your I is equal to square root of n, exact square root of n is your I. Here it not assigning, it is a comparison, okay. This is comparison. If your I is n, not this less than, this is s, your I is exact equal to square root of n, assume this. So in this condition you have only add only I, nothing after this. just add I only, plus equal to I. Do not add n by I, because n by I is equal to always I, because I cross I is equal to n. I cross I is equal to n. In this case, if I is equal to square root of 1 n, so it means I cross I is equal to n. And if we divide, and if we plus n by I here, so what is n by I? Here we divide n by I, so here we also divide n by I cut, so this I is remaining, but it included here before, so in this case we have to also check, we have to mention this, so here just write code for this. Okay, so here we check if I does not equal to square root of n. If I does not equal to square root of n, so our sum is equal to I plus n by I. Okay, else sum plus equal to I. It's a very simple code. Here we check if I, your sum does not equal to n, then return 0, else return 1. So let's check our code is run fine or not. Okay, n was not declared. Where we use n? Square root of n. Oh, here we use small n. Here we don't use this operator. So we alter this condition. We write we can write also like this. Okay, so our output is good. Let's check for 28. For 28 we will see that it will be 1. Okay, so our output is 0, but why? So let's check it. If I cross I does not equal to n, so we have to sum plus I and n by 2, n by I, yes, it's okay. And if it is equal to sum, if n does not equal to I, so return 0. Why n does not equal to I? Okay, let's see what is sum. Oh, sum is 50, but why? I plus starting I with 2 up to I less than equal to square root of n. And sum plus equal to I here. Okay. Here we have don't write else. Here we have to write if I is equal to n, then sum only I, because it will go in all. And for doing this, we one thing is forget. we have to check first this, if n modulo I is equal to 0. Okay, if it is equal to 0, then do it. Okay, so one will be so here. Yes, okay. If n modulo I is equal to 0, it means I is a factor of n, and we have to check first I cross I, because I is not equal to square root of n, so we have to add I plus n by I, which is the another factor which belongs to after the square root. N by 2 belongs to after the square root. This is our square root, this is after the square root, and this is before the square root numbers. Our i's belong to before the square root number, and n by I is after the square root number, as we see here. So here, and if n is except I is perfect square root, so the sum is take only plus equal to I. Okay, and here if sum does not equal to n, then return 0, otherwise return 1. So instead this condition we check here, we can check it here, or if n is 1, then it will show return 0, so we remove it here. Okay, so this our code is ready. Take submit it. Okay, this test case is not passed because here we take in long, here we should use long and then submit. Yes, so our all test case is passed, as we see here, and this is a very simple and easiest code. Only we have to think about optimize approach, and I hope it is very easy to understand why here we take I plus n by I, and why here we use only I plus 1. Okay, and why n is equal to 1, then it will should return 0, because 1 is not a perfect number. So thanks for watching my video, and please like, subscribe my channel, so I will upload like these videos daily. Okay.